Hello, Mr. Minnick here, helping my Java students with Tracing Static Methods worksheet number 2. This worksheet is tricky, so please pay attention to this video very closely. In exercise 1, we have 3 methods. Make a note of that. We have a method named main, which we always have methods named main in this part of our course. We have compute av, and we have a method called mystery. I collapsed the curly braces only to make the question smaller so it doesn't take up more space on paper. For good style, you would put these curly braces, arrange them differently. At any rate, we start tracing this code by jumping in to the first line of the main method. So this line of code declares 2 variables. I made nice little columns here so you can test check and trace the variables, values. 10 is initialized there to num1, and num2 is initialized to 5. The variable num3 is declared as a double. Make a note of that, as opposed to an int in the case of num1 and num2. Num3 is not being set equal to 0. Do not put a 0 there. It's actually initialized to whatever the return value of compute av is. Compute av is a method. It's a method that I created and typed out right here. There's the function definition. And the method's body is right there. So we have to do whatever that tells us to do and return that value back up to this spot, and whatever number that works out to be is what num3 will be initialized to. If you're a trusting person, you'll just assume that 7.5 is the value that all of this simplifies to, and therefore that num3 is initialized to 7.5. But sometimes, perhaps on the AP exam, or a coworker at work has a logic error or some other problem that causes an answer to not be what you would expect. Compute av might not work correctly, and maybe it's only 7 that gets returned for some reason, or it's rounded up to 8. So you must trace this code carefully to make sure at this stage of our school year that it's working the way that it does. Okay, so what happens? 10 and 5 are the parameter values that appear in the parentheses here of the method call, the function call. So 10 and 5 are passed as parameters, and they plug in for x and y respectively. Why x and y? Because this is the function compute av, and this is the call statement where compute av is being called. So the 10 knows to plug in for the x, and the 5 in this 1-to-1 correspondence knows to plug in for the y. Now this is kind of odd. We have integers being passed, and they plug in for parameters that are doubles. That's fine. Technically speaking, this 10 is really 10.0. And this y that I'm keeping track of here locally in this compute av method is technically it's 5.0 or 5 point if you want to represent it that way. It may not make a difference, but it is illegal to do this from an int to a double. Okay, now we execute the code in the body of the compute av method. So we follow the order of operations. X plus y is simply 10 plus 5, that's 15. 15 divided by 2.0. Well, 15 is a double. If it were an int, it wouldn't matter. You can divide an int by a double, and either way, it will end up that all this simplifies to 7.5. 15 divided by 2 is 7.5. Is that system out printing? Are we done with the problem? No, there's no system out print here. The 7.5 is returned next back to where the 10 and the 5 came from. So all of this is now replaced by 7.5. we can trust that compute av works as advertised. Is this a system out print statement? No, it's not. The 7.5 on the right-hand side is the initialized value of the variable num3. So finally, we know what we can put here. We can put a 7.5. Wow. All of that tracing just to realize that 7.5 is the value that is num3 is initialized to. We called the method compute av to figure that out. So we've finished executing those 2 lines of code. We have one more line of code to execute. Looking closely, num3 is currently 7.5, so that's really 7.5. We are calling the function mystery. I say function, method, same thing. The function mystery is typed out here. It's not built into Java. It's something I created as part of this worksheet. It needs a parameter that's a double, so the 7.5 can properly be passed and plugged in for x. It's a double, so the 0.5 is stored there properly. It's not truncated or anything. And now we execute the line of code that's in the body there of the mystery function. Well, this is complicated. We put a 7.5 in everywhere that we see an x. That 7.5 immediately gets added to 2 according to order of operations, so that simplifies to 9.5. So really we have an x comma x plus 2, which can be thought of as 7.5 comma 9.5. And these are parameters that are being passed through these parentheses to the method compute av. So again, this method compute av is being invoked. It's being called. This time, the function mystery is calling it. Earlier, compute av was called by the function main. In the name of reusability, compute av gets around. Okay, so 7.5 and 9.5 are being passed as parameters, and they're plugging in for x and y. And there was a 10 and a 5 there. Well, that was like totally erased. When this ended the first time, that was sort of erased from the memory of the computer. But you could just put lines through the former numbers 10 and 5 if you wish. The important thing is that you put a 7.5 there now, and you put a 9.5 there on your scratch paper. So that if I grade this worksheet, I saw scratch work, even if it's a little messy, be as neat as possible though. I can see that you knew that these two numbers, 7.5 and 9.5, were passed here as parameters. So now we have to execute this line of code. 7.5 plus 9.5, that simplifies to 17, by the way. 17 divided by 2, that simplifies to 8.5. So we have an 8.5 that gets returned. It's not system out printed yet. Where does it return? Don't think that it returns up here, because it does not. The 8.5 returns back to where the compute av function was most recently called. So this is where the 8.5 gets returned to. It gets returned back to here, and all of this just simplified to 8.5. And it gets returned to wherever mystery was invoked. Where's the call statement for mystery? Oh, back up here originally. Long time ago, we passed something down here, and now the 8.5 is returned back up to this spot right here that simply is replaced all in this set of parentheses with an 8.5. And because we're now in the parentheses of the print ln method, it is printed as an 8.5 as my answer to question number 1. Okay, well that was a complicated problem. At this point, you should probably attempt question number 2 on your own, and the same for number 3, of course, and hope that you get the right answer. But I will give you some tips here and give you a hand up. In question number 2, exercise 2, it gets a little bit dicier. We have a main method and a mystery 1 and a mystery 2. Main easily stores a 1 there, initializes that to 3. That's easy. But now look at this call statement here in system out print. We work from inside the parentheses out, so we have to get to the bottom of that. What does that simplify to? Well, num2 is the first parameter in order, so that's really a 3 because of that 3, and num1 is really this 1. So the first mistake that students make is they're in a hurry, especially on the day of the AP exam, I fear, and they just send 1 and 3 in the wrong order as parameters down here. That would be like a typical trick on the AP exam. Or just a logic mistake by a coworker. Anyway, let's give you a little bit more help now. The 3 and the 1 are stored there, and they plug in for X and Y. So I'm going to put a 3 there in my scratch work and a 1. And what does this do? Well, that's simple math. And whatever number is returned there, whatever that simplifies to, that number plugs in now for all of this. So what you have at the end of all that is simply some number. I don't want to give away everything, but some number, I'll call it question mark number. That question mark number plugs in here, and it's before the comma 5. So mystery 1, oh no, I did that whole problem wrong. I called mystery 1 when this was really mystery 2. Why didn't you stop me, people who are watching this video? Now I have to redo everything. Okay, let's try to give you the help. See how easy it is to make a mistake when AP exam makers are trying to be tricky? Anyway, I'll go quickly. 1 and 3, 3, comma 1 in that order. Because that's a mystery 2, that means we're looking at this method down here. And that 3 matches up with Y, not the X. The Y is listed first. So that 3 plugs in right here. That 1 plugs in for X. It's the order that matters. Java does not alphabetize and reorder parameters. So there's a 1 and 3 here. And they, of course, plug in, this is X, so that's 1, comma, Y, which is 3. And now we have to pass those as parameters to mystery 1. Here's mystery 1. And the 1 and the 3 plug in, are passed as parameters and plug in for X and Y. So there should be a 1 there and a 3 there. And now some number, this simplifies to some number. We'll just call it question mark. That question mark gets returned, but to where? Well, it gets returned to here, because that's where these parameters were passed. That's where the function call was. So all of this simplifies to whatever question mark is. Where does it get returned? It gets returned wherever mystery 2 was called. Well, that was up here. So this question mark then takes the place of all this. And we're not done yet. There's no system out print quite yet. System out print comes later, but now we find ourselves in the set of parentheses that match up with this mystery 1 here. This outer set of parentheses, question mark, comma 5 to mystery 1. Question mark, comma 5, that question mark plugs in here. That 5 right there plugs in for Y. So this is question mark and 5. And then all this happens again, whatever that simplifies to. I'll call that double question mark. That gets returned to wherever mystery 1 was last called, which is right here. So all of this, all of that simplifies to whatever double question mark is. And that, friends, is what system out prints. You have to figure out what double question mark is to finish that problem. Either way, if I give a quiz or there's a multiple choice question on the AP exam that's of this level of difficulty, where a function calls a function and different parameters are switched the order and 1s and 2s are easily confused, you better get it right. Because they always have all the wrong answers look right if you made one simple logic mistake. Okay, question number 3 while I'm at it here, the last question on this worksheet. I'm not going to do it for you obviously, but maybe I can give you a tip. Let's see what's tricky about this. We have a main method. It calls mystery 1, so at some point something plugs in there. Oh, now we have a return statement, which according to order of operations, we have to first calculate that, and we also kind of calculate that. Whatever that sum works out to be, that sum is returned back up to here. So this X for mystery 2's call statement plugs in there. And after all that returns back to this spot, this X plugs in there, and that return value plugs in to this spot, and then we add the oval plus the rectangle, and all that returns back up and is system out printed. So this is tricky in a slightly different way than the other 2 exercises are. Just keep your eye on the ball, stay focused on these parameters, and keep track of ints versus doubles, because sometimes a decimal number truncates, and every once in a while an error occurs if it's not coded properly. Good luck with that, and I look forward to seeing your worksheets when you submit them, or the results of the quiz that will be a takeoff of this worksheet.